Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet. In this we were doing 3 topics and the pattern was BFS traversal. So following this pattern today we'll see the question which is left side view, and the prerequisite of this problem is first one, which is binary tree level order traversal. So let's read the problem statement. It says we will be given the tree and we have to print the left view of the binary tree. First let's try to understand what is left view. So left view says ki if you have this tree, right, and you are standing towards the left side, so what all nodes you can see? Can I say 1 will be visible? Now in the next level 2 will be visible, 3 will not be because 3 is behind 2. Okay, now 7 will be visible, again 7 we can see, but 4 and 5 are behind 7, so these numbers or nodes will not be visible. Similarly 6 will be visible because at this level 6 is present towards the right side, correct? So why I said the prerequisite of this problem is the binary tree level order traversal, because if you know that also na, and if you will print the level order node values here, 2 3 for level 1, 7 4 5 for level 2 and 6 7 for level 3. So level 0, level 1, level 2, level 3. And now what are we expected to print? Can I say 1, 2, 7 and 6? Okay. So answer will be 1, 2, 7 and 6. So if you visualize this very carefully, 1 is here, 2 is here, 7 is here and 6 is here. So can I say we are looking for nothing but first element of every levels? Can I say that? Yes. So it's very obvious ki if we know how to print the level order traversal, so we will iterate in every levels, okay, and print the very first value of it. But remember, this will be the brute force approach. Why? Because when only first index value was important, then why you have inserted the rest node values inside this level or answer? Because it will take extra space complexity, correct? Then to save it, like to save the extra space complexity, what we can do is ki while traversing in the levels, whatever index we are iterating on, we can simply check ki if that particular index is equal to 0, then we can say this node we want. So in the outer answer we'll just add that. How we do so? Let's see. But before that, let's read the constraint. It says the number of nodes can be 0 also, means base case needed, means what if root is null? Then we have to return the empty array. And the maximum number of nodes can go till 10 power 5. Why it is important to read the constraint? Because if you are thinking about n square time complexity code, then in this case 10 power 5 and 10 power 5 becomes 10 power 10. And you know, because you have watched our time and space complexity video, if not, I'll attach the link somewhere here. So there we have discussed that beyond 10 power 8 it's not safe, and for sure at 10 power 9 and 10 power 10 operations will give us TLE. So the BFS code we have already discussed that we will create a queue data structure, and in that queue data structure we will first insert the root value if it exists, means if it is not null. So first we will check the base case. Now until we have elements in queue, correct? What we do first, we calculate the size, if you remember. Yes, because that many times only for loop will run to store those nodes in that levels, correct? Okay, so we'll calculate size. Now after that we were supposed to create our array list here, if you remember, list of integer, and then we named it level is equal to new array list. Okay, why we do so? Because in level order traversal we were supposed to insert the values in these levels, correct? So this line of code is nothing but creating these sublists inside that outer list, but we don't want these sublists, remember, we just have to save the very first node values in the outer list, correct? So we will not create this list for sure. Now what we want to run our for loop for int I is equal to 0 till I less than size, yes, and I plus plus. Now inside this what we want to do? For sure we have to pop all such nodes which are present in that particular level. Okay, so we will pop node is equal to q dot poll. Done. Now what we want to do, we will check like this node is supposed to be inserted in our answer only if that index was 0. If its index is 0, then we can say that these are the very first elements of that level, correct? So we'll simply check if I is equal to 0, then only in the answer add what? Node or node dot value? Node dot value. Done. Now what are we supposed to do? Now instead of all the node values which are not present at I is equal to 0, we can say ki skip those, means we don't want to insert in our answer array, okay. But for all the nodes which are here in the queue, we want to insert their childrens. Why? Because suppose if you feel ki 2 has been inserted, 3 is not needed, so why we are inserting 3 dot childrens? It is important. Why? Because what if 2 children is not there? Then for sure 4 is going to be the very first element of that level. So hence it is very important to insert all the children of all the nodes. So now we'll write ki if the node has its left child in queue, we have to offer node dot left, correct? Similarly, we have to check ki if node has right child, yes, now in the queue offer node dot right child. That's it. Now after this what we are supposed to do? We can say our for loop is over, correct? So after completion of every levels, because for loop is nothing but it is iterating for every levels. So we don't want to do anything. Why? Because whatever the task was to insert the very first element of all the levels, we have already did here. Now we can say ki after coming out of this whole while loop also ki return the answer, because it consists of our left nodes, which is nothing but left view of the binary tree. So let's dry run for this. The very first value, the very first node 1 will go inside it. Now we will pop 1, okay, and here we'll go like this for loop will run for one size, yes. Now we'll pop, after that we'll check is our I is equal to 0, yes. Then in the answer we will insert, in our answer we will insert 1, correct. Now after that we have to check ki the node which is 1 has its left child and right child, yes. So 2 and 3 will also get inserted in the queue. Now next time we will calculate the size again, and this time the size of the queue is 2. So this time it will run for 2 times. First time we will pop 2 and the index for it is 0. So yes, in the answer 2 will go. We will pop 2, answer 2 will go. Now we will check, does 2 has left child and right child? 2 has only left child, so 7 will get inserted here. Now again we will go here, for loop was supposed to run for 2 times, so this time 3 will get popped out. But now the 3 index is not 0, so 3 will not get inserted in our answer array. But 3 has its children, so for sure they will get inserted, okay. So 4 and 5 we will insert, 4 and 5. Again why I am saying we will insert 4, 5, because what if 2 does not has any child, then in that case 4 will become the first or 0th index value. So 4, 5 also we have inserted. Next time we will go here, again queue is not empty, we will check size. This time this for loop will run for 3 times. First we will pop 7, 7th index is 0, so definitely in the answer 7 will get inserted. Now 7 does not has any child, it's okay. Now we will pop the next element which is 4, correct. 4 has its left child 6, so 6 will get inserted, but 4th index was not 0, so it will not get added in our answer. Similarly next time 5 will get popped out, correct, but again 5 index is not 0, so will not insert in the answer, but 5 has its child, so 7 will get inserted in the queue. Next time size of the queue is 2, so for loop is going to run for 2 times in this level. Again we will pop 6, index of 6 was 0, so 6 will get inserted here. But next time when we will pop 7, 7th index is not 0 and it does not has any child also, it will not get inserted here. So at the end when we will pop 7 also, our queue will become empty here. After coming outside, whatever answer array we have prepared, this is nothing but the left view of binary tree. So this was the BFS code. Now let's the time and space complexity. We have iterated to all the nodes, can I say? So for sure we have inserted every node also in the queue. So in the worst case, the space complexity will also go for O of n, correct? Why I am saying this? First time you have inserted 1, so size of the queue was only 1. Now then you have popped 1 and inserted 2, 3. Maximum size is 2. Then you inserted 2. Suppose this is a full binary tree. Let's say it does not have these children, but it is a full binary tree like this. Okay. So 1, then you popped 2, you will insert its child. Let's say 8. So you will insert 7, 8. Maximum size till now 3. Now you will pop 3, 3. Insert children's 4, 5. 4, 5. Maximum size of the queue till now 4. So in the worst case, the maximum size of the queue will be nothing but the last level. And you know the last level consists n by 2 number of nodes, which is linear only. So space wise also it is O of n. Now talking about the time complexity, it is number of exactly O of n. Why? Because you are popping every number of nodes. Every node you are popping, correct? Yes. So it's exactly O of n. So can we write the code for this? Here is the code I have already written for you all. First we will create the answer array. Now the base case, if root is null, we need to check because the number of constraints, it says a minimum number of nodes can be 0 also. Now we will create a queue and we will offer the very first root in the queue. Now until it becomes empty, we will calculate the size, run the for loop for that size. Now we will pop node. We'll check if the index is 0, then only that node is supposed to get inside the answer because that will be the left view. Otherwise, we will check and put if left and right child exist. After coming outside the whole while loop, we can say our answer is ready. So now let's run the code. As you can see, the time and space complexity was O of n. So definitely this will be faster because the constraint was 10 power 5. Okay. Now this was a code in Java. Here is the code in C++ with a similar approach, and here is the code in Python with a similar approach if you are from Python background. Okay, but this was the BFS code, and you know na, we are trying to do BFS and DFS both code if it is possible. But before going for DFS approach, depth first approach, there is one more similar problem which is right view of the tree. Like we have left view, we also have right view of the tree. So in our sheet, we have mentioned that question as well. So let's read that problem. So here is the problem statement. As you can see, instead of checking from the left side, now we have to check from the right side. Okay. So if you understood the level order traversal and the left view, you can simply think, okay, yes, this is nothing but in the levels, you have to check last size index. Can I say? So if the length is for first level, if the length is 1, so you have to check for size minus 1th index as per the 0 based indexing. Now for the level 2, we have two elements, so 0th index and first index. So again you want the last element, so last element is nothing but size of that level minus 1. Yes. So if you talk about constraint, here the minimum number of nodes can be 1. Means we do not need to write the base case in the breadth first search approach. And the maximum number of nodes can be 10 power 5. Although we have just saw how to do it linearly, so we can definitely write. So in the right view tree, can I say we have to print 1, 3, 5 and 7. Why? Because 2 will become invisible because of 3. Similarly 7 and 4 will not be visible and 6 will also not be visible. So if we talk about the level order traversal, what are we supposed to print? We are supposed to print the last index value, which is nothing but 7, 5, 3 and 1. Correct? Yes. So you already know what line of code we have to change here. We did level order traversal and we don't want to print all these level values to save our space complexity. So we decided to insert only that node value in the answer for which the index was 0. But here what we want? We want to insert only that node value for which the index is, can I say, size minus 1. So the only line of code which we have to change is ki if I equal to size minus 1. Okay. So now let's do the dry run for it. First we will have queue data structure. First 1 will go and here is the answer array we have. Okay. So what we will do, first we will pop 1. Before that size was 1, so this for loop is only supposed to run for one size. Now we have popped 1. Correct. Now we'll check, is the 1 index is equal to size minus 1. What was the size? 1 minus 1 0. So is I 0 is equal to this? Yes. So this one is supposed to be inserted in our array. Now what we will do, next time we have popped 1, so definitely 2 and 3 are there left and right children, so it will get inserted. Next time we will pop 2, we will go here and check, size was 2, so index will be 0 or 1. So here we will check, current for 2 the index is 0, but we are looking for 1. So are they same? No. So 2 is not supposed to go inside the array. Now we will insert the children of 2, which is 7 in the queue. Next time we will pop 3. Now we will check index of 3, which is 1. 1 is equal to size 2 minus 1 1. So is 1 is equal to 1? Yes. So now this node value, which is 3, is supposed to be inserted in the answer array. So we will insert 3. Now it's time for 3's children's, which is 4 and 5. So we will insert 4 and 5. Now next time we will pop 7, correct? But before popping 7, the size of the queue is 3. Okay, so first index will be 0. We'll pop and we'll check, is 0 matching with size 3 minus 1 2? Is 0 equal to 2? No. So this 7 is not supposed to go inside the answer array. Now 7 children, no, it's not there, so we'll not insert. Next time we'll pop 4. Now when we'll pop 4, again we'll check, index of 4 is 1, but size minus 1 is 2. Are they matching? No. So 4 is also not supposed to be inserted in the answer array. Now it's time for their children. So we'll insert, we'll pop 4, okay, and we'll insert child of 4, which is 6. Now it's time for popping 5. Now index for 5 is 2, size minus 1 is 2. Are they matching? Yes. So 5 is supposed to go inside the answer array. That's it. Now children of 5, which is 7, will get inserted. Now again size will calculate, size is 2, so this time it will run for 2 times. First I is equal to 0, is it matching with 2 minus 1, which is 1? No. So 6 is not supposed to go, so we will pop 6. We do not have children for 6, it's okay. Next time we will pop 7, index of 7 is 1, size minus 1, which is 2 minus 1 is 1. Are they matching? Yes. So in the answer 7 will go inside. After coming outside, we will check कि now our queue has become empty. So this is the answer array which we have to return. Is it the expected? Yes. So the only line of change we need to do in the code is कि if I is equal to 0, then only add, it will give you left view. And if I is equal to last index, if you are adding, then it will give you right view. And that's it. So now I'll go in the left view. I will copy this much line of code. I'll go in the right view. I will paste it here, okay, I'll paste it here. Now what I will do, instead of 0, I will write size minus 1. Now let's run the code and now let's try to submit this. So as you can see, it was very similar, so that's why I tried to complete both of these questions in the same video. So this was a BFS approach. Similarly, you can do in C++ also and in Python also if you are from Python background. So I hope you understood. If yes, then this was your BFS code, and let me know in the comment section if you have any doubt. I'll attach the sheet link and my social media links in the description. And that's it for this video. Let's meet in another video with some more interesting questions, topics and patterns. So then keep learning, take care of yourself and your family too.